In the following, we would like to show how you can plan even very large layouts with little effort using the Solidworks add-in Lino 3D layout. This is shown using the example of a high bay warehouse, but this is just an arbitrary example to demonstrate that you can go a long way with clever Solidworks modeling in conjunction with Tacton design automation and Lino 3D layout. The motto is here, so to speak, don't be afraid of big layouts. This is roughly how the layout should look like. We will put this together in the following in an amazingly short time. In the right part, we see the warehouse area with the high racks and the stacker cranes. Here in the middle on the left, the picking area, and on the far left, the loading and unloading area with a foreman's cabin. But now we really want to build such a layout ourselves. To do this, we will open a factory building from the Lino 3D layout library. As you can see, there are already corresponding areas drawn in for orientation. To create such a layout in SolidWorks from a 2D architect plan is not really witchcraft and will not be discussed further here. As a first layout element, we drag a configurable pallet rack from the group High Bay Warehouse into the layout. In the top view it looks unspectacular. We will rotate it a bit and take a look at the configuration options by playfully entering a few values. By the way, this movie was recorded with a German user interface, but of course you can switch the user interface to English. I set the total length to 29 meters. It is impressive how quick other heights can be realized. Let's try to set the height to 20 meters. And back to the default value. Later, the correct height is controlled with a single input for all high racks. The depth can also be changed in no time, as you see. Let's move to the shelving layout. Here you can easily set the number of shelves and the number of partitions. These changes take less than a second. But I change it back to the default value, then the number of partitions is calculated depending on the length. We can also have the shelf start at, say, 3 meters high. Or control the total height implicitly by the height of the highest shelf. As you can see, the rail of the stacker crane is also already present, and I can control the aisle width here, which of course then also determines the distance of the next row of shelves. We set an aisle width of 2 meters. But that was only the warm-up. I discard all input values with this icon and first roughly fill the upper high rack storage area by dragging in another rack. Here, the option double rack design would be a good choice. Now the first stacker crane could be placed. The red dots in the aisles show us where this is possible. With the sliders, we move the device to the 6 meter position and bring it also immediately to 6 meters height. Of course, we can't see the ladder in the top view. If the aisle becomes longer later, and it will of course, 2 stacker cranes in the aisle also make sense. We move it to 2 meters. The aisle seems to be a bit short with 1 meter. We set it to 1.5 meters. And find that the loading platforms also adjust accordingly, and all in less than a second. We complete the quadrant at the top right and add more pallet racks. In the set direction, we have now used the space up to the escape route. Now it's time to set the right length. Okay, we can fill 29 meters here. This is only a mouse click with Lino 3D layout because the length is defined as a so-called chain global parameter. Let's quickly distribute some stacker cranes to the rows and simulate their positions. In the top view, our layout still seems to be simple, but if I turn it to a 3D view, we have already built up quite a substantial structure here. Now the task is to fill the quadrant at the bottom right as effectively as possible. Since we need a similar structure, we work with the copy function of Lino 3D layout. We select the top 3 rows and bring them to the clipboard. From here, we simply drag and drop them into the bottom. However, we need some changes. In this area, we want to use the full shelf depth of 2.4 meters, corresponding to the long side of 2 Euro pallets. Since this is a chain global parameter, the change is applied to all shelves in the lower quadrant. We roughly position the lower shelves and find that one more end shelf fits at the bottom. We drag in another one . It automatically adjusts in length because length is a chain global parameter. Since the lower quadrant will be used to store light but bulky building materials such as insulation, we can make the shelves a little lighter there. We reduce the number of shelves in the bottom shelf in the lower quadrant to 5 and the number of partitions to 7. Since these values are not chain global parameters, these values are not automatically inherited by all the shelves below. We therefore use the transfer parameters function to update the other bottom shelves with them. To do this, I select the parameters to be transferred and the target components that should take over these parameter values. Now let's turn our attention to the picking area. Various conveyor belts are to be placed here. Since we have already done similar tasks before, let's go to the My Library area here and drag the predefined components into our layout. Here at the top first a single picking belt and here then a pair of picking belts. Below, we use the roller conveyor with a crane. We have already learned the technique for setting down the other objects. Now we place the foreman's cabin. Here we have also configured something similar before and saved it in our private library. We find that here in the category Hall Equipment. Of course, it is very easy to build these structures individually. We move the foreman's cabin to its designated place. However, it is still too small for the number of people working here. No problem, it can be reconfigured. To do this, we go to the frame and find that there is also a 30-foot version here. The back wall has automatically adjusted in length. For the front, we now must decide what we would like to have here. We go into the container, exterior elements, wall structure and drag in another door segment and a window segment. As you can see, you can also change the color for the whole foreman's cabin here. Our client wants chimney red, a warm color in a sometimes cold hall. In the loading area, we need some forklifts. We quickly find one in the library and drag it into the appropriate area. And immediately another one. which we then rotate here by 90 degrees with Lino Triad. We drag another employee into the layout, who now looks as small as an ant in the scale of the huge hall. Now that we are almost finished with the layout, the bombshell bursts. The architect has told us that the hall height changes. The new height is 30 meters. To change this would be a nightmare in many programs, but it only costs us 2 mouse clicks because the height is a global parameter in our modeling. Even with this size, the assembly can be rotated absolutely performant and without delay, as you can hopefully also see in the movie. Remember that in the upper right quadrant we had not specified the number of shelves, so they were evenly distributed over the entire new height. Unfortunately, even nowadays nothing works without a drawing, so we will make one. As you can see, the suggested scale of 1 to 25 is of limited use. I'll choose a non-standard scale of 1 to 65 here, now the hall fits in the template. How long do you think it will take us to dimension it now? Well, with Lino 2D Fix it's a matter of seconds. One click on the Create Annotations button and we have all the relevant single and chain dimensions. Sure, we still need to do some manual work here and move a few dimensions to the best place, but the big job is done. Curious about how all this works? Talk to us and request a demo license today.